Hi, my followers.
In basics of mathematics classes, today classes going on concepts are divisibility rules. Divisibility rules means any big number given, then we can easily identify that number is divisible by 2 or 3 or 4 other numbers. Okay, those rules we are going to know in this video, and listen carefully. Now today concept is divisibility rules. Divisibility rules. Observe. So step in rule 2, divisibility rule number 2. So any big number given, that number is simply we can identify that number is divisibility by 2 or not. So now we are going to know the rule how to identify any big digit number, any big digit number divisible by 2, divisible by 2, then whose last digits whose last digits last digits are 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Whenever any big digit number having last digit is 0, 2, 4, 6, 8, then that number is can easily divisible by 2. So example I am given randomly one number. So it's this big digit is simply divisible by 2 or not? Yes, it is simply divisible by 2 because of whose last digit is 2. Next, one more example. 0, 87,530. When we are going to divide by 2, then it takes more time. Okay, but you finding the last digits, so we can say this number is, this big digit is simply divisible by 2. Yes, so because of here last digit is 0, any big digit number having last digits 0, 2, 4, 6, 8, those numbers are easily divisible by 2. Next, one more example. 6, this number is divisible by 2 or not? Yes, because of whose last digit is 6. So let's you go and divide 9 j 18, 0, take remainder 6, 3 j 0. We are getting remainder is 0. Those are called we are divisible. So these are the rule of 2. Any big digit number divisible by 2, then whose last digits are 0, 2, 4, 6, 8. Okay, those kind of any big digit numbers easily divisible by 2. Okay, next rule is rule 3. Next, divisibility rule of 3, number 3. Okay, number 3 means any big digit number any big digit number any big digit number is divisible by divisible by divisible by 3, then sum of whose digits then sum of whose digits sum of whose digits sum of whose digits becomes sum of whose digits become multiple of 3, multiple of 3, or result get 0, then that number is simply divisible by then that number is simply divisible by then that number that number then that number is simply divisible by simply divisible by 3. Okay, any big digit number is divisible by 3, then sum of whose digits become multiple of 3 or result of 0, then that number is simply divisible by 3. What is the meaning of sum? Sum means addition of those digits. So take example I am randomly given number. Let's you go and check that number is completely divisible by 3 or not. So what I given condition, then any big digit number is divisible by 3, then sum of whose digits become multiple of 3 are 0. Sum of whose digits, sum means addition of all those numbers, digits 7, 7 plus 8 plus 4 plus 2. Answer 15, 19, 21. Yes, 21. If you have, there is no multiples, then you again you going to again sum. So 2 plus 1 is equal to 3. Yes, 3 is the multiple of 3. Say na, or 21 is the multiple of 3. 3 7 ja 21. So any result becomes 0 or that result become multiple of 3, then that complete number is divisible by 3. Okay, one more example. 8, 32. So this number is completely divisible by 3 or not, then you follow the conditions. Any big digit number is divisible by 3, then sum of whose digit becomes multiple of 3 or result becomes 0. So sum of whose digits, let's you go and sum their digits. 8 plus 4 plus 8 plus 3 plus 2. So 12 plus 20, 23, 25, 25. 25 is not multiple of 3, or you are going again multiple. 2 plus 5, then it gets 7. 7 is not multiple of 3. Okay, that's why this number is not divisible by 3. So this number is this number is not divisible by not divisible by 3. Okay, the divisibility of rule is whose last digit 0 2 4 6 8, and divisibility of rule of 3 is sum of whose digits becomes 0 or multiple of 3, then that complete number is divisible by 3. Okay, next rule of 4. Next rule of 4. Rule of 4. Any big digit number, any big digit number divisible by 4, divisible by 4, then whose last two digits, last two digits divisible by 4, then complete number is divisible by complete number divisible by 4, divisible by 4. Example, any big digit number divisible by 4, then condition whose last two digits divisible by 4, then complete number is divisible by 4. So example, I am randomly given. Let's you go and check whose last two digits is divisible by 4 or not. Don't you check complete number, just you check last two digits is divisible by 4 or not. So now I am going to last two digit is 72, so I am going to divide 2 4 sorry 4 4 1 ja 4, remainder getting 3, take carry 2, so 4 8 ja 32 0. So when you are getting last two digits is divisible by 4, then this complete number is divisible by complete number is divisible by 4, divisible by 4. One more example, any big digit number any big digit number is divisible by 4 or not. Any big digit number divisible by 4 or not, then rule is whose last two digit is divisible by 4 or not. Let's first you check last two digits. This is the big number, this completely divisible by 4 or not, you simply identify through the rule. So let's you go and check last two digits. Last two digits is 84, then divide this last two digits by 4. So 4 2 ja 8 0, and remainder getting 4, 4 1 ja 4, s 0, s is getting. So this complete number is this number also divisible by 4. Okay na? One more example, let's 1873, this number is divisible by 4 or not. Let's you go and check. Next, last two, what is the condition? Last two digits first you check divisible by 4 or not. So 4 1 ja 4. So you are getting remainder 3. 4 8 ja 32. So remainder getting 1. So remainder when you getting 1, then this complete number is not divisible by 4. Okay, remainder always getting 0. In that condition we are saying divisible. If remainder is getting something, then we are saying that is not divisible by something number. Okay, so I hope all of you understand. Conditions 2 3 4 is over. Next, rule 5, divisibility of rule 5. What is the rule 5? Any big digit number, any big digit number divisible by 5, then whose last digit, becomes 0 0 or 5, 0 or 5, then that number is completely divisible by 5. Example, you take any big digit number, but let's you go and check whose last digit becomes 0 or 5. In this number, in this big digit number, there is last digit 5 or not? Yes, 5. Then this number is completely divisible by 5. Next, any big digit number, who check, let's you go and rule through the 5, let's you go and check the whose last digits, how much? 0. Then this number is also completely divisible by 5. Next, one more example, let's you go and check this number is completely divisible by 5 or not. Through the rule, any big digit numbers divisible by 5, then whose last digit becomes 0 or 5. So let's here check here, last digit is 2, so this number is not divisible by 5. Okay, this number is not divisible by 5. Next, observe rule 6. Rule 6, any big digit number, any big digit numbers divisible by 6, there is two conditions is applicable. 6 is the factor of 2 and 3, so when any number is divisible by 6, then that number is applicable of rule 2 and rule 3. When there is when the application of rule 2 and 3 is possible, then that number is also divisible by 6. Let's show this. Any big digit number is applicable by rule of 2 and 3, then that number is simply divisible by 6 also. Next, we check here. Example 128. First you check the rule 2. What is the rule 2? Any big digit number is divisible by 2, then whose last digit 0 2 4 6 8. So this is 2, this is 8, then it is divisible by 2. Yes. Next you are going to check the rule 3. What is the rule 3? Any big digit number is divisible by 3, then whose sum of all digits become multiple of 3 or becomes 0. So now you are going to sum. So it is 11. 11 is not multiple of 3. So this is not divisible by 3. Any one of the condition is false, then that is not divisible by 6 also. Any one of condition, in these two condition, any one of condition is false. Any one of condition is false, then that number is not divisible by, divisible by 6. In 6, because of 6 is the factor of 2 and 3. 2 3 is 6. So any number is possible to divisible by 6, then that number is applicable for two rules, rule 2 and as well as rule 3. Any one of condition is failed, then that number is not divisible by 6. One more example. You are going to check this number is divisible by 6 or not. Then first this number is applicable two conditions. So first, this number is divisible by 2 or not. Let's go check. Yes, this number is divisible by 2 because of whose last digit is 6. Yes, this number. Next, we are going to check rule 3. Rule 3. Let's see, you are going to checking the rule 3. So its number is divisible by 3 or not. What is the rule 3? Sum of all digits. 1 plus 8 plus 3 plus 6. So 9 plus 12 is equal to 18. Yes, 18 is the multiple of 3 or not? Yes, 6, 3, 6, yeah, 18. So this number is applicable two conditions. Then 836 also divisible by 6 also. This two number is also divisible by 6 also. Okay, I hope all of you understand this rule of 6. Okay, in the rule of 6 there is two condition. First, rule 3 also applicable and rule 2 is also applicable. Any one of the condition is not applicable, then that number is not divisible by 6. Okay, what is the meaning of divisibility? Divisibility means that's remainder getting 0. Now I am dividing this number 1836. So 6, throw this 6, it is divisible or not? Let's you go and check. 3 ja 18, 0, take remainder 3. 0 is not sufficient, then I am putting 0 and taking one more digits. So 6 6 ja 36. So remainder getting 0. When we are getting remainder 0, then we can say use word divisible. If remainder getting something, then we are going to say word not divisible. Okay, don't confuse.